Students, we were discussing about cranes. Now, in the picture, you can see a top running double girder crane. But what is a crane? Let me discuss you first. A crane is a type of machine generally equipped with hoist rope, wire ropes or chains, and sheaves that can be used both to lift and lower materials and to move them horizontally. It is mainly used for lifting heavy things and transporting them to other places. The device uses one or more simple machines to create a mechanical advantage and thus move loads beyond the normal capability of a human. Cranes are commonly employed in the transport industry for loading and unloading of freight, in the construction industry for the movement of materials, in the manufacturing industry for the assembly and heavy equipment. The first known crane machine was the Shadoff, the water lifting device that was invented in ancient Mesopotamia, modern Iraq, and then appeared in ancient Egyptian technology as well. The construction cranes later appeared in the ancient Greece, where they were powered by men or animals and used for construction of buildings. Larger cranes were later developed in the Roman Empire, employing the use of human trade wheels, permitting the lifting capacity of higher weights. In the High Middle Ages, the harbor cranes were introduced to load and unload ships and assist with their construction. Some were built into stone towers for extra strength and stability. The earliest cranes were constructed from wood, but cast iron and steel took over the coming of the Industrial Revolution. For many centuries, power was supplied by the physical exertion of men and animals, although hoist in water mills and windmills could be driven in the harnessed natural power. The first mechanical power was provided by steam engines in earliest steam crane being introduced in the 18th or 19th century, with many remaining in use uh, well into the 20th century. Modern cranes usually use IC engines or electric motors or hydraulic systems to provide a much greater lifting capability than it was previously possible. Although manual cranes are still utilized where the provision of power would be uneconomic. Now, cranes exist in enormous variety of forms, each tailored to a specific use. Sizes range from the smallest jeep crane used inside workshop to the tallest tower cranes used for constructing higher buildings. Mini cranes are also used for constructing high buildings in order to facilitate construction by reaching tight spaces. Finally, we can find larger floating cranes generally used to build oil rigs and salvage sunken ships. Uh, now, coming to the mechanical system of cranes, uh, the term stability comes actually. For stability, the sum of all moments about the base of the crane must be close to zero. Now let me go through that. Bridge, runway rail, end trucks, hoist, trolley or crab, bumper or buffer, controls, essential terminology when specifying overhead cranes. This is the hook height, this is the clearance part, this is the bridge, the rails, the runway beam, and top of rail, top of corbel, site clearance, building frame, lighting fixture. These are the crane travel, these are the hook approach. So this is how the crane terminology essential in overhead cranes are concerned. So there is something called crane capacity, and the long travel, the direction of the travel for bridge along the rails, cross travel, hook height, runway height, site clearance, vertical clearance, clear span, runway length, hook approaches, end approach, bridge, trolley, lift speed, electrical requirement. These are all uh, part of this crane. So let me show you this figure once again. This is hook height, clearance, the bridge, vertical clearance, top of rail, side clearance, building frame, rail, yeah, hook, crane travel and hook approach. These are all part of the overhead crane terminology. Now crane duty group. So this is the crane duty group. There is class A, class B, class C, class D, class E, class F, and the four load classes is for hoisting: L1, L2, L3, and L4. Yeah, this is four load cycles. So this is the chart what you can see regarding a crane terminology. Yeah, this is another chart given on very detailing, that is bulk cathedral and in combination with buckets. This is H5 not applicable, and duty cycles, AFM service classification. Yeah, different load spectrum of average duty operating time. These are also part of crane handling. Okay, please note this part, that this T is equal to average daily operating time, H is the average hoisting height, N is the number of work cycles per hour, capital T is daily working time, and capital V is hoisting speed, that is meter per minute. So these are various crane types. So let me go through hoist, but hoisting will be another part. So let me close my lecture right now, and this is all about cranes part 2. Thank you very much.